So this is the logarithm practice worksheet. I'll do some of the problems, maybe a couple different ways, or how I would do them. So whenever you're doing a problem like this, that is the exponential right there. We got to get it by itself. So we will add 5 on both sides. And some students, when they're doing these, they go a little too fast. And like right now, some students think, oh, 4 to the 1/2 is 8. But that's not how exponents work. So on this one, I sometimes do an ln, or any logarithm that you want. That allows you to bring the exponent in front. And then you can divide by the ln of 4 on both sides. And in that case, we could go to our calculator, do the ln of 8, divide by the ln of 4. So I can do the ln of 8, make sure you close it, divide by the ln of 4, and we're getting 1.5. Another way to do this problem is 4 to the x is 8. I could make this 2 squared to the x power, and I can make this 2 cubed. And then stacked exponents multiply, so I would multiply those two exponents, so that's 2x. And now because the bases are the same, I can set the two exponents equal to each other. And I get 3 halves. So remember, sorry, I forgot to write the 1.5 over there. And the last way some students will do this problem is when they get to this 4 to the x equals 8, they can rewrite it, and you can go log base 4. Remember, logarithms are always equal to the exponent, so it'll be equal to x because that's our exponent, and you put 8 there. And then again, on our calculator, we can hit math, go up to this log base feature. 4 was our base. We had 8 inside there, and we also get 1.5. So that's 3 different ways to solve that particular problem. All right, on the next one, remember our variable is inside the logarithm. And so I'm going to rewrite this. Base is 5. Logarithms are always equal to the exponent, so it's equal to 2. So 2 is my exponent. And then we have the 3x plus 1. Now we just solve for x. So this will be minus 1 minus 1. 5 squared is 25, minus 1 will be 24. And we'll divide both sides by 3, and x is 8. And you can always go back now to the original. So if you have time on the exam, you could go back to the original and plug it in to make sure that's working. All right, the next problem, they're not there, but it's really a base 10 and a base 10. And because we are adding, we're going to go log base 10. And inside, I'm going to multiply now those two things. So that'll be 5x times x minus 1. So that's what I call the squishing together property. So we just squish those things together. The variable went inside the logarithm, so I can rewrite this. So this will be 10 base. Logarithm is always equal to the exponent, so that's my exponent. And then it will be equal to this stuff. Now, right now I'm going to distribute, and that's 5x squared minus 5x. So now we are putting our brain into what I call quadratic mode. I'm going to subtract 100 on both sides. So we have to solve 5x squared minus 5x minus 100. We have to solve that quadratic. Now, to make our lives easier, I can factor the 5 out, but some of you might just go to the quadratic formula to get your 2 answers. But if you factor the 5 out, x squared minus x minus 20, x minus 5, x plus 4 is how it would factor. Now, if I set each one of these equal to 0. This doesn't give us a solution, so you can disregard that one. But you set x minus 5 equal to 0, and you set x plus 4 equal to 0, and so my answers are 5 and negative 4. Now remember, plugging these back in, you have to be careful. But when we take negative 4 and I put it back in there, I'm going to have the log of negative 20. That's not good. Or when you put it in there, you also end up with logarithm of negative 5. Can't have negatives inside the logarithm. So we don't cross it off just because it's negative. It puts a negative or leaves a negative in the logarithm, and so the only answer will be 5. All right. I didn't leave myself much space, but on this particular problem, we just start pulling things away. So let's go minus 1, minus 1. And some students you might think, oh, I'm going to multiply those two things together, but you'd be breaking PEMDAS. So we're going to, there are different ways. You can divide by the 1/4. I'm going to multiply by 4 on both sides. Same thing. Now that gets rid of that. So now you have 4 to the 2x is equal to 16. And depending on how you do this, go back to problem number 1 and you can see the 3 ways that I solve it. I'm just going to rewrite this. So I'm going to go log base 4. Logarithms are always equal to the exponent. Put my 16 there. 4 to what power is 16? That's a 2. You can certainly use your calculator on that one. And then when you divide by 2, I get x is 1. So I'm going to stop here, 1 through 4, and I'll do the next set in another video.